In our upper left-hand corner, we have our external thread data table, and all the information that's inside this table can be found in a machinist handbook. To the right of it, we have our front view with these section lines coming down, splitting our part in half, and we can see this down here in our bottom view. Going up back to our front view and over to our right view, you can see we have some clarifications on some radiuses and some chamfers. At the end of our part here, we also see a detailed view of our threads, which could be seen here. Down in the bottom left-hand corner, we have an isometric view, and it also has a detailed view of the threads, indicating its major, minor, and pitch diameters. This detailed view is not necessary, and we will not be creating this as part of our drawing. Let's jump over to Fusion 360 and create our drawing. The very first thing that we need to do in Fusion is we need to indicate that this face here that I just clicked on is the front of our part. What we're going to do is kind of orient our part so this face is facing towards us, and up in our upper right hand corner we're going to click on the word in our view cube that is facing us, and this will orient our part nice and square to our workspace. Afterwards, we're going to right click on the view cube and set our current view as our front. Notice our view cube has changed, and now this is the front of our part. We're going to save our part, and then we're going to change our workspace by going up to our toolbar and down to Drawing from Design. In our pop-up window here, it's asking for, do you want everything in this modeling workspace to be a part of your drawing? We do. We are creating a new drawing, and the template that we are going to be using can be seen in a previous video on how to create a title block template. And then press OK. The very first view that Fusion 360 is going to land for us is our front view, but we're going to change some information in our pop-up window. We're going to change its style to visible edges, its scale to a 2:1 ratio, and we're going to turn tangent edges on. We're going to land this position in the kind of in the upper center location, and then press OK. Notice one thing that I'm seeing here is we're seeing some thread edges appear. So we're going to double left click on this and uncheck thread edges and then close it out. And notice that view goes away. The next view that we're going to land is our right view and our isometric view. We're going to go back to our toolbar, under Drawing Views, down to Projected View. And we're going to click on our front view, and drag our mouse to the right, giving us a right view, and drag our mouse down to the bottom left, giving us an isometric view, and then press Enter on the keyboard. Our isometric view down here, we're going to change its visibility from a wireframe to a shaded part by double left clicking on it and changing its style to shaded with visible edges. The next view that we're going to land is our section view. Back to our toolbar to Drawing Views, this time down to Section View. We're going to gesture our mouse over to the center of our part after we've clicked on it. And notice we see these construction lines appear. We're going to left click here, drag our mouse to the other side, left click again, and press Enter. And then drag our mouse down, giving us a bottom view. And then press OK. One last view to add. This time we're going to take a look at our right view, and we're going to add a detailed view to it. So Drawing Views down to Detailed View. We're going to click on our right view and place our detail circle kind of in the center here and drag our mouse out. If you make a mistake, it's okay because we can always adjust this afterwards and then land our view right below. As I mentioned before, if you made a mistake here, you can always click on your detail circle and grab these handles, making the circle larger or smaller. You can also click on the handle in the center and adjust its orientation. When you do so, your detail view will automatically update. While we're here, we're going to add our dimensions in for our detailed view. We're going to go D on the keyboard, and we're going to go take a look at our thread relief first. We're going to click on this flat area of our thread relief, and then the flat area on the other side, and then click. And the next thing that we're going to click on is the crest of our thread on one side to the crest of the thread on the other side, and then click again. We want to extend our measurements off our part, so after we land them, we can actually click in the center here and drag our mouse over and give us an extension line. We can do the same thing on this measurement. Notice our measurements here are only stated to the 10,000ths column. We're going to change this in the annotation settings, which can be found in the bottom center of our workspace. We're going to turn on display trailing zeros and change our linear dimension precision to the thousandths column. Afterwards, we're going to add in some clarifications to these measurements by double left clicking on it. We're going to click in front of this bracket here and insert the diameter symbol. We're going to click at the very end of our bracket and then add in the width of our thread relief at 65 thousandths. We're going to repeat the same thing over here for our major diameter. Clicking in front of the bracket, adding in that diameter symbol, and then adding in the length of our threads. At any point, if your measurements have moved around like mine have, you can always readjust them. Before we leave this view, we're going to add in our chamfer here. We're going to use a text with the leader line, and we're going to click on this angled here, this angled line, and type in chamfer 35 thousandths at 45 degrees. And this is typical 2 instances. I'm going to add in a little return here to kind of break up that text box. Before I leave my detailed view, I'm going to click on this detail B, change the overall size of detail B to 100 thousandths by highlighting it and changing its height, and then closing this out. And then I'm going to move this detail B a little bit closer to my pictogram. Our detailed view is fully defined now. I'm going to jump up to our right hand view. We're going to add in some chamfers up here. So text with the leader line. This time we're going to click on this angled line here. We're going to type in chamfer, shift enter, 10 thousandths at 45 degrees. We're going to insert the degree symbol, and this one is typical 3 times. The next thing that we're going to add in is some radiuses over here. So D on the keyboard. We're going to click in the bottom here where our flange meets. And there's a little radius here. We're going to drag that out. Right click, press OK. This feature is typical 4 times, so typical 4x. And then close that window out. There's one thing I forgot on our detailed view. We're going to come in and move this maybe over here. I forgot to add in our radiuses here. So I'm going to go D on the keyboard, this time picking that radius there. And that is typical 2 times. And this needs to be a max measurement. And then I'm going to move my chamfer over a little bit to get it out of the way. Like so. Now we have our detailed view and our right view done. We're going to jump over to our front view. And we're going to add in the 2 diameters here. So dimensions down to diameter dimension. First diameter we're going to add in is the outermost portion of the front of our part, which is 830 thousandths. And then the next diameter we're going to land in is the overall outside of our part. Again, we can readjust our dimension lines after we set them. That way everything's in alignment. Our front of our part is fully defined now. We're going to jump down to our bottom view. Our bottom view here, we're going to have to create some construction geometry before we start adding our dimensions in. So we're going to go to our toolbar, to geometry, down to center line. We're going to click on the vertical lines that make up the outside of our flange here, and then right click and press OK. We're going to drag these center lines by clicking on the center line, and we're going to drag it down to the very bottom of our part, anchoring it there. Then we're going to click on the upper portion of our center line, and we're going to snap it to the front or the top of our part by using this construction lines that appear. Be mindful that this center line needs to be perfectly at the very top of your part. Otherwise, if it's not, and you anchor your datum location to it, all your measurements will be off. So take your time on this part, zoom in if necessary, and notice how my center line exactly terminates on the edge of our part. After we do this, we're going to go to Ordinate Dimensions. And as I mentioned before, we're going to land our datum at that location. And then we're going to drag our other 0 location off of the top of the part. We're going to change these 0 locations primary precision by double left clicking in it. And in the pop-up window, change their primary precision to 0. And repeat that on the other one. Before we continue, we're going to add in some construction geometry because we have these lines that are going to be intersecting over here. We're going to go to geometry and down to edge extension. We're going to extend this line and this line so we see that intersection point. This intersection here is going to allow us to be able to reference it later. What we're going to do now is go back to Ordinate Dimensions. And we're going to start adding in our dimensions. The very first dimension we're going to anchor off of is the endpoint of this radius. And then we're going to reference off of our previous extension line from our 0 location, dragging that out. Then the center location of that extension, edge extension, again referencing off of our previous extension lines. The endpoint of the chamfer here. And then lastly, the endpoint on the outside of our part, all of which we're referencing off of the previous extension lines. Now that we have our horizontal measurements in place, we're going to start adding in our vertical measurements. This particular measurement here, we're going to reference off of the endpoint of our arc on both sides. We're going to drag our mouse to the center where those intersect and drag our mouse over, and again referencing off of the previous extension line, the back side of this flange, the intersection of those two lines, the back side of our post, back side of our thread relief, and then the very end of our part. Now that we have our ordinate dimensions in place, we're going to add in some other dimensions. So we're going to go D on the keyboard. These other dimensions are going to clarify some of our measurements. We're going to go from this vertical line to this vertical line. And that gives us the diameter of that post. And then the vertical line and the vertical line that make up the center of our hole. Afterwards, we're going to right click and press OK. And we're going to drag those dimensions over to the right side of our part. We're going to double left click on these, insert the diameter symbol, and then type in this information. This hole can, that's the wrong symbol. This hole needs to be drilled 600 thousandths max, and you are going to be using a 140-degree included angle drill bit. We'll close that out. And then again, we can always move this around. We're going to adjust this other measurement here, and this will be 500 thousandths. We'll try to line that up with the one above it, like so. We're almost done with our bottom view here. We're going to use a text with the leader line. This time we're going to reference our threads. These are going to be 3/8 16 unified course. These are going to go down 350 thousandths minimum for our depth, and we can close that out. And I did forget one thing here. We're going to double click on that, and these are class 2B threads. Our bottom view is fully defined now. What we're going to do now is we're going to create our thread data table. We're going to go up to our toolbar, down to tables, and down to table again. And then in our pop-up window, we're going to choose an empty table, and we're going to snap this empty table to our upper left-hand corner of our sheet. Like so. And then we're going to click in one of these cells and delete our columns down so we only have one column visible. Once we have one column visible, we're going to double left click in this and start typing in our information from our table. After you type this in, we're going to bold this up, and then we're going to close this out. So our header for this will be external thread data. These are 3/8/16 unified course class 2A threads, because these are external threads. We're going to click in cell number 2. This is our major diameter. We're going to bold this up and then close it out. Cell number 3 is going to be our max of our major diameter. We're going to change its justification to left, middle left. And before we leave this particular cell, we're going to hit Tab a couple times, and that will give us another couple rows to work with. This particular one is going to be labeled our pitch diameter. And we're going to change its justification to center. And afterwards, we're going to bold this up and change its justification. And then it looks like I forgot to bold this one. And there we have it. We've got our thread data as part of our table. It's a good opportunity. Double check your spelling and your measurements. Before we finish up, we're going to zoom down to our title block. We're going to double left click on the lines that make up the title block. This will enable us to edit the attributes. We're going to click on material and type in 6061 T6 aluminum. Then we're going to click in our revision block here. And this is revision A, and we'll close that out. Again, this is a good opportunity to kind of reorganize your workspace, make it easy to read and comprehend. Other than that, this concludes the tutorial on how to create a drawing of the Titan 91L.